Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
Welcome now to question 5, part A, CSEC Math Exam January 2012 video solution. Now question 5A gave us this diagram, and it said that there are two triangles, JKL and MLP. KLP is a straight line, so the two triangles are side by side, and that's on a straight line. It said JL is parallel to ML, so this line is parallel to this one. That's why we have these arrows here. And once you hear of parallel lines, in a tricks question, you start thinking about Z angles. Z angles are equal, and also parallel lines make the same angle with a straight line that they cross. Alright? Also gave us angle JLM as 22 degrees. That's this one. JLM, 22 degrees. Angle LMP is 36 degrees. And the question also said that the length of LM is equal to MP, but there's no indication of the diagram of that. So let's put that in first. Right? That the LM is equal to MP in length. Right? So we can place these marks on the lines to indicate that they are equal. So what we have here really is an isosceles triangle. So we can also state that. Now we are required in this question basically to find the angles, right? These angles, these unmarked angles in the question, alright? So what I'm going to do, I'm going to put some symbols in to represent the angles, and then we work our way through finding each angle. Now because this is an isosceles triangle, these two base angles are equal. Right, so we can name these two angles, call them theta for the time being, and then we calculate theta. And then we can call this angle up here KJL alpha, and we can call this angle here beta. That's JKL, angle JKL, we can call it beta. And then we'll call this angle phi, that's angle JLK, that angle phi. And the question basically wants us to find these angles. They want us to find this angle MLP, that's theta, which we have here. Then it wanted us in part 2 to find alpha, that's angle LJK. Then in part 3, question wants us to find angle beta, this one, that's angle JKL. And then part 4 wants us to find angle phi, which is angle KLJ. So those are the angles that we're required to find. This one, then this one, then this one, and then this one. Right? I'm going to do them one at a time. Right? So to find this first angle here, we're going to use the fact that the total angles in this isosceles triangle is 180 degrees. These two are equal. Right? And so we can write an expression for that. That the 2 theta plus the 36 degrees will add up to 180 degrees. Total angle is 180 degrees. And so if we transpose to make theta the subject, what we'll do is subtract firstly the 36, and then we'll divide by 2. So you subtract 36 from both sides first, and then you divide by 2. Because if you subtract 36 first, you're going to be left with 144, and then you divide by 2. So angle theta is 72 degrees. So the answer for this angle here is 72 degrees. This one is also 72 degrees. Alright. Now part 2 is asking us to find alpha. And what we have is this line crossing these two parallel lines. So basically forming a Z angle here. That's a Z angle. Right? These are Z angles right here. Right? Are alternate angles. So this angle is equal to this one, right? Simply because these two lines are parallel and this line is crossing both of them. So we form a Z angle right here, or alternate angles. So alternate or z angles are equal, and therefore alpha is equal to 22 degrees. As simple as that. So that's it. Alpha is 22 degrees. And then now we want to find angle beta. Right? We now want to find angle beta. Now this is a straight line. This is a straight line. And this line is parallel to this line. So the angle that this line, this parallel line makes with this straight line is the same that this parallel line will make with this one. Right? So that's it. That's how we're going to find beta. Parallel lines make the same angle with another straight line. So this is a straight line and these are parallel lines. So the parallel lines make the same angle with that straight line. So this angle is equal to this one, and we know this one is 72 degrees. So therefore beta is 72 degrees. And then now to find phi here, we're going to say, okay, total angles on this straight line is 180 degrees. We could also say that total angle in this triangle is 180 degrees. The result will be the same, but let's use the line. Total angle on this straight line is 180 degrees. So therefore this angle plus this phi that we want to find add up to 180 degrees. So let's put that in. Right? The phi plus the 22 degrees plus the theta is 180 degrees. We already know that theta is 72 degrees from here, and therefore we can find phi by subtracting 22 and subtracting 72 from 180 degrees. And that will give us phi equals 180 degrees minus 22 degrees minus 72 degrees, right? And so that works out to be 86 degrees, and therefore this angle is 86 degrees. That's the answer for question 5A. Let's move down now to question 5B. Now in question 5B, we are given this diagram with these two triangles, PQR, and an image of a transformation P prime, Q prime, R prime, looking like a reflection to me. Now the first question is asking us to write down the coordinates of P and Q. P is right here, Q is right here, and if you observe the axes, right, you see that this 1 unit, 2 units, 3 units, 4 units, and observe this axis, you'll see 1, 2, 3, 4. We have to make sure of the units on the axis before we start. So P therefore would have coordinates 2, 1, an x coordinate of 2 and a y coordinate of 1. And then Q would have coordinates 4, 3, 3, x coordinate of 4, y coordinate of 3. So those would be the coordinates for P and Q. 2, 1, and Q would be 4, 3. P is 2, 1, Q is 4, 3. Those are the coordinates. Part 2 is asking us to describe the transformation which maps triangle PQR onto triangle P prime, Q prime, R prime. Now it looks like a reflection, but there are certain properties of reflection that we must check before we confirm that it is a reflection. It looks like a reflection in the x-axis, but let us check first the properties of reflection so we can confirm that it is indeed a reflection. Now the first property of reflection that we want to check is orientation. Reflection is the transformation that reverses orientation. Right? So let's check the orientation first. The orientation of this object is PQR, so it's an anti-clockwise orientation. PQR is this direction, so the orientation of this one is anti-clockwise, while on this one PQR is actually clockwise, right? And we can show that, right? So this one has a clockwise orientation. P to Q to R is clockwise around the diagram. P to Q to R on this object is anti-clockwise, while P to Q to R on the image is clockwise. So the orientation was reversed, and we have therefore satisfied the first criteria for reflection. Now, the second criteria for reflection is the distance from the mirror line. Now, in reflection, image distance from a mirror line must be equal to the object distance from the mirror line. Now, we're talking about each point. Right? The image distance of each point must be equal to the object distance of each point from the mirror line. And we are saying that the x-axis is the mirror line. So let's look at each point. P first. P is 1 unit. The perpendicular distance is 1 unit from the mirror line, x. And the image is also 1 unit. For Q, it is 3 units. 1, 2, 3. Q is 3 units from the mirror line on this side, and the image is 1, 2, 3 units on the other side of the mirror line. And then R is also 3 units from the mirror line on this side, and R prime is 3 units on this side. So this confirms that object distance is equal to image distance, and so the criteria for reflection over the x-axis are satisfied, right? And so we can confirm that the transformation which maps triangle PQR onto triangle P prime, Q prime, R prime is in fact a reflection in the x-axis. And we can go ahead and write that. Transformation that maps triangle PQR onto triangle P prime, Q prime, R prime is a reflection in the x-axis. And then now we are asked in part 3 to write down the coordinates of the image of a translation 3, -6 on the points P, which we know is 2, 1, and Q, which we know is 4, 3. Now, what will this transformation do? This translation will move each point in the object 3 units to the right and 6 units downwards. Or we can say 3 units in the x direction, in the positive x direction, and 6 units in the negative y direction, 6 units downward. The negative here means that we move downwards in the y direction. 3 here means we move 3 units in the positive x direction, that's to the right. Okay, and we can do and show it for each point. Let's look at P first. P is going to move 3 units to the right and 6 units downwards, right? So if you look at this diagram here, it's at 3 units to the right and 6 units downwards. So P double prime, let's call the image P double prime, will be right here. So it's 3 units, 1, 2, 3 units to the right, and then 6 units down. 1, 2, 3, 4, 5, 6. So P double prime, the image of P under this translation is right here. What are the coordinates of this point? That's 5, -5. 5, -5. For Q, it's the same thing. 3 units to the right, 6 units downward, starting from here. So let's show that movement as well. So 3 units to the right and 6 units downwards. And if we call again the point, the image of Q under this translation, Q double prime, then Q double prime will be right here. And what are the coordinates of this point? 7, -3, -3, 7, -3. Again, it's 3 units to the right, 1, 2, 3, 6 units down, 1, 2, 3, 4, 5, 6. So that's it. Another way we could have calculated the image is to add 3 to the x coordinate of P, that would take us to 5, and subtract 6 from the y coordinate of P, that would take us to -5. We could have done the same for Q. Add 3 to the x coordinate from here, that would take us to 7, and then subtract 6 from this y coordinate, which would take us down to -3. That's why we're having these 2 points, right? And then we can therefore show the result of the translation. P double prime is 5, -5, and Q double prime is 7, -3. 2 plus 3 is 5. 1 minus 6 is -5. 4 plus 3 is 7. 3 minus 6 is negative 3. So we could have done it by calculation, or we can do it by construction as shown on the graph. So that's the answer for that question. And our next question is going to be question 6 in our next video. Alright, see you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.